Rules of significant figures. The following rules are applied to find the number of significant figures for a given number. 1. The zeros at the end of whole numbers are not counted as significant figures. For example, 3,900 has only two significant figures, 3 and 9. This is because only these two numbers are considered for any possible rounding. In other words, we can round this number only to the nearest 1,000 or 10,000, as the other digits are 0 and it is not necessary to do any rounding with them. 2. The zeros at the beginning of any decimal number are not counted as significant figures. For example, the number 0.0036 has only two significant figures, 3 and 6, as we can obtain a meaningful rounding only to the nearest hundredth and thousandth, in which the two above non-zero digits are considered. This is not the case of zeros at the end of a decimal number. These zeros are all counted, as they determine the precision of a result. In other words, in practice is not the same thing to write 0.040 meters and 0.04 meters in the first case. The value is measured with a precision up to 0.001 meters, 1 millimeters therefore, while in the second case, the precision of measurement taken is up to 0.01 meters, 1 centimeters therefore. 3. Any zero in between two non-zero digits, both in whole number as well as in decimals, are always counted as significant figures. For example, the number 0.0407 has three significant figures, 4, 0, and 7. The other two zeros are at the beginning of a decimal, so they are not counted. Example: how many significant figures do the following numbers have? A. 403500. B. 3.0040. C. 0.00150. Solution: A. 403500 is a whole number. In such numbers, only the zeros at the end are not counted as significant. Therefore, this number has four significant figures, 4, 0, 3, and 5. B. 3.0040 is a decimal number. In such numbers, only zeros at the beginning are not counted. Therefore, this number has five significant figures, all digits are significant. C. 0.00150 is a decimal number too. However, in this case there are some zeros at the beginning, which are not counted as significant. Therefore, this number has only three significant figures, 1, 5, and 0. Finding the number of significant figures by expressing the number in decomposed, standard form. We can identify the number of significant figures by writing the number in the standard form. In such cases, only the part of the number that comes before the powers of 10 is considered as significant. Let's consider again the numbers of the previous question to explain this point. We have A. 403,500 is equal to 4.035 times 10 to the power of 5. In this case, the number has four significant figures, 4, 0, 3, and 5, as they come before the powers of 10. B. 3.0040 is equal to 3.0040 times 10 to the power of 0. Nothing changes to the number, so there are five significant figures in it, all digits are significant. C. 0.00150 is equal to 1.50 times 10 to the power of -3. This number has three digits before the powers of 10, so it has three significant figures. All these results were obtained earlier, when we calculated the number of significant figures of the previously mentioned number by means of the first method. That is all for lesson 2.1.8. To continue this tutorial, please watch 2.1.9 Applications of Significant Figures. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.